We're going to look here at how to do the elimination method to solve a system of two equations with two variables. We've got equation 1 in blue, equation 2 in red. Now the first thing I like to do with elimination method is to get both equations into this form where you've got the x value, then the y value, then the equal sign, then the c value, which is the number by itself. So for the first equation, the 2x doesn't need to move, it's already in the right place. But the y is on the wrong side of the equal sign, so it has to move over. When it does that, it becomes a minus 3y. Same thing for the 5, it's a positive 5. Going onto the other side will become a minus 5. We'll repeat the same thing for the next equation. The negative 4x term is already on the left of the equal sign, so it can just go in as negative 4x. If it doesn't change sides of the equal sign, then the sign doesn't need to change either. Same for the negative 5y. It will stay on the left, so it will stay as negative 5y. The 12, however, positive 12, does have to move over to the right-hand side, so it will become a negative 12. What we've got now is our two equations just rearranged. Nothing has changed in these equations though. Next, we're going to have to eliminate one variable. We could choose either x or y. I'm going to choose y here because it just doesn't matter. Since we have different numbers in front of the y's, we're going to have to do something to these two equations to make the number for y, the coefficient for y, the same. I'm going to multiply the first equation by the 5 that we see in the bottom equation, and I'll multiply the second equation by the 3 we see in the top equation. When we multiply every term through, 2x times 5 is 10x, minus 3y times 5 is negative 15y, and negative 5 times 5 is negative 25. So this is my equation 1 again. Once again, nothing has changed because we've multiplied it all by the same thing. The same again for the red equation, multiplying everything by the number 3. We can now see that the y terms have the same coefficient. Negative 15y in both. Negative 15y in one and positive 15 wouldn't matter because we can deal with both. But since I've got two negatives, I'm going to have to subtract them in order to make them cancel out. If I had a positive and a negative, I would add the two equations. So taking equation 1 minus equation 2, we can see we've got 10x minus and then negative 12x. Two minuses make a positive, so that leaves us with 22x. Then we've got negative 15y minus negative 15y. Because the two minuses make a positive, that leaves us with negative 15y plus 15y, and that brings us to 0, which is the whole point to get rid of the y variable. Same thing for the coefficients. Negative 25 minus negative 36 is the same as negative 25 plus 36. And that leaves us with the number 11. Okay, so the result of equation 1 minus equation 2 leaves us with 22x. The y variable has been eliminated, and that is equal to 11. We can divide both sides by that number in front of the x to find out that x is equal to 0.5, a half. So we have to solve for y now by substituting x back into either of those equations. It won't matter which, because they'll give you the same answer. So taking the first equation, 2x minus 3y equals negative 5. Remember, we're substituting in the value of 0.5 for x, so that leaves us with the equation 1 minus 3y equals negative 5. I'll move the 1 across by minusing from both sides. Now I'll divide by the negative 3 in front of the y to find that y is equal to 2. Writing these as coordinates, our answers are x equals 0.5 and y equals 2. And we can see from looking at a graph of these two original equations that the intersection point is over x equals 0.5, y equals 2.